Hi everyone, just wanted to take a minute to talk about a mixture problem so that way we are clear. And as a reminder, I did want to point out that throughout this school year, we are going to encounter the mixture problems a number of occasions. So if you don't fully get it at this point, don't worry, we're going to have a few more opportunities throughout the year. So let's read this question and see if we can understand what it's asking us. So we're saying a scientist needs 10 liters of a 20% acid solution for an experiment, but she only has 5% solution and a 40% solution. To the nearest tenth of a liter, about how many liters of the 5% and the 40% solution should she mix to get the solution she needs? So let's think about this really quickly. We're starting off by saying at the end, I have 10 liters. I have 10 liters specifically of a 20% solution, but I have 10 liters at the end of something. And I'm combining two other mixtures together to get this 10 liters. So that means if I put in X liters of the 5% solution, X plus however many liters of the 40% solution I have to put together has to be 10, right? So that would mean I essentially have 10 minus X liters of the 40% solution. All right, so these are just a way to represent how many liters of each I'm doing. Now, I do have to identify which one is which, right? It doesn't really help me if I just leave it like this, because this, as I said, it's just going to simplify down to 10. And 10 does equal 10. That's true. However, we are dealing specifically with the percentage of acid. So it's more important for us to be aware of the content, the acid content of each. So to do that, we're going to multiply the amount of liters of each by the percent of its acid. So the percent acid, if it's 20%, we're just going to multiply by 0.2. The 5%, 0.05. The 40%, 0.4. And all we're doing on this is we're converting the liters of solution to the liters of acid, right? So we're getting this so that we're saying acid plus acid is equal to amount of acid, which is what we're looking for, as opposed to saying amount of this solution plus amount of that solution is equal to amount of a different solution. We're really just getting everything in so that it's the same form by doing this. So 10 times 0.2, that one's easy, luckily 2, 0.05x plus 4 minus 0.4x. Now you can see over here, this is the actual setup that we were looking for if we were answering this problem B. But anyway, now we're going to solve this. So we do have to combine our like terms. 2 is equal to negative 0.4x and 0.5x, right? So ultimately, when we combine those, that's negative 0.35x, and then the plus 4. We'll subtract the 4. Minus 2 equals negative 0.35x. Now we do need to be careful. Luckily, they're both negative, so when we divide a negative by a negative, it will be positive. But if we made a mistake somewhere and lost a negative and we got a negative answer, we have to think to ourselves, does that make sense that I'm putting in a negative amount of liters? No, it definitely does not make sense. So we cannot do that. So I am just quickly checking in my calculator what that number comes out to. So when we divide by negative 0.35, by negative 0.35, we ultimately get that x is going to be equal to 5.7. Now it told me to round to the nearest tenth. So we would be saying that we are putting in 5.7 liters of the 5% solution, and that would mean that the remaining 3.3 liters would 4.3 liters. I'm sorry, 4.3 liters would be the 40% solution. And we could check our answer on that one as well, if we so desired. All right, I hope this helps. And again, please let me know if you have any additional questions. Thank you.